out on this absolutely wonderful afternoon. An article in the Times in January had this headline, 1970s Voyager to cross the final frontier. And I read it, and it was quite a short article. And I thought, oh, 1970s, when did that happen? That was a busy time. And I didn't remember the launch. There'd not been much about it in the press ever since, other than the specialist press. So it was all a bit of a mystery to me, but enough of a mystery that when I did a little bit of reading, I discovered that behind it, there's just an amazing tale, not just of ingenuity, but many other things. They launched two of them. Two satellites, launched a couple of months apart. And I discovered that after a very, very long gestation period, almost 50 years ago, these things were launched, and they're still flying today. It's quite a remarkable tale. But before I talk about the technology and whatever, a bit of context, because I'm not a space expert by any stretch of the imagination. So I thought, well, what is space? And what I've heard about the Milky Way, and I've heard about the universe. All the galaxies are the universe. And our Milky Way, the bit that we sit in, is about 200 billion stars. Now, I can imagine that no one's actually counted them. This is an estimate. And there are 2 trillion galaxies, give or take a few, I imagine. And once you get out here, it's just twice as dark as black and very, very cold. There's nothing there. And it's a space, however, that's full of theories, it's full of unknowns, it's full of speculation. And what the Voyager set out to do was try and find out something about it all. By the way, this is us. We are quite insignificant in the scheme of things. And this is not to scale, as you'll see in a moment. And what we call the solar system, that's the bit that's influenced by the sun, is this bit. And the rest of the galaxy is interstellar space, that huge, huge void. And this is what our galaxy looks like. And our solar system sits about here. It's just a tiny fraction of it. But what was important was the getting to the moon at the time. So that's where space is. But we've heard about the space race. And when Russia launched Sputnik, and then they launched a man into space, America panicked. This was at the height of the Cold War, as much as Khrushchev and Kennedy were trying to pacify things. This was seen as a significant threat to the United States, that Russia was ahead. They'd put Gagarin into space, they'd launched Sputnik, which was not much bigger than a tennis ball, but shocked the world when it was launched. And all it did was send out a beep, 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 but that was enough to frighten people. And America decided that we are going to go to the moon. And as Kennedy put it, we're going to go to the moon, not because it's easy, but because it's hard. And indeed, it was hard. So this is where we sit, and this is roughly to scale. The sun represents 99.8% of the solar system. So all of us, the outer planets, these are called the big boys, the outer planets, the inner planets, and us, are totally insignificant in the scheme of things. The sun is 99.8% of everything that we know in space. And our moon is only 250,000 miles away, almost on our doorstep. And the first rocket, liquid-fueled rocket that ever was sent up 100 years ago by this gentleman, Robert Goddard. And there's a Goddard Space Center named after him. The rockets are a little more sophisticated today, but they look the same. In July 1969, America put 2 men on the moon, and Life magazine, which I meant to bring with me, which I found on the internet about 20 years ago, was published. So they met it. He said we were going to do it in this decade, and in that decade, they did it. So now back to Voyager. So the solar system contains all these things. These planets are solid, including us, Mars, Venus, and Mercury are solid lumps of rock. Most of them haven't got much on it, except for ourselves. The biggest one is Jupiter. Jupiter is entirely gas planets, and then the last two, Uranus and Neptune, are ice planets. And Neptune is 32.5 billion miles away. So our moon is 250,000 miles away. This is 2.5 billion miles away. And they're called the big planets. And NASA at the time was quite preoccupied with putting the men on the moon. But someone was asking, well, what about these big guys? Why don't we go and have a peep at these big chaps? And we all orbit the sun. The further away you are from the sun, the slower you travel. Only 12,000 miles an hour if you're that far out, and 100,000 miles an hour if you're there. They never quite look like this. Right? They're never in this sort of configuration. And this is us. We're traveling at only 67,000 miles an hour. So when we launch something, a second after we've launched it, where we launched it from has moved. So they have to calculate all of these sorts of things. Normally, these are scattered all over the galaxy. But in 1964, a young man called Gary Flandreau, who'd only just graduated with his doctor's degree, and had joined the Jet Propulsion Laboratory, which was part of NASA, was a very bright lad. And he thought, hang on, there's something happening in 1977 that we can take advantage of. So this is way back now in 1964. So he's talking about in 13 years' time, something's going to be happen that we can take advantage of. He'd spotted two phenomena that, if they came together, if one happened and they exploited the second phenomena, they could go and have a peep at all four. Never happened before. And what he was talking about was an alignment of the big four planets. And again, this is an artist's representation. They don't line up like that, and it's not important that they do. But the important thing is that they are in such a place that you could go and have a peep at all four on the same trip. Because once you launch a satellite, that's it. It's only going to go that way. You can adjust its trajectory, but not significantly. And this alignment of the planets happens only every 175 years. The last time it had happened, wooden sailing ships were the norm. That's how we saw the world, through very primitive binoculars and so on. But a number of people had observed the fact that people like Galileo and people who'd written about it could say it does happen every 175 years that these are in alignment. So unless you do it now, was Flandreau's argument, you got to wait until 2152. So why not do it? And the other thing that he observed, the other phenomena which had been used and pretty well understood by people in the space industry, is what's called the slingshot effect. And that is to say, if you launch something at a planet which has gravity, and if that planet is spinning, and you get close enough to it, the gravitational pull of the planet will catch hold of whatever it is you've launched. And if it's spinning at that speed and you're doing this and it's spinning, you accelerate. And that's called the slingshot effect. And it had been quite well understood and used for some time. The interesting thing was, with the planets in alignment, they could go and have a look at all four. They could get the slingshot effect on the first one and get to the second, then get the slingshot from the second and go to the third, get the slingshot from the third and go to the fourth, and then carry on out into space. If you didn't have alignment, you could do one, and that would be it. You go past it and off you go. Who knows where you go next? So these two things coming together was what inspired Gary Flandreau to start a campaign to go and have a look at these four planets. And we have to launch in 1977. It's 1964. NASA is quite preoccupied with putting men on the moon. That's where the money is going. But they are solving a lot of the technical problems of putting objects, big objects, up into space. And the idea was, by the time, his idea was, well, we'll launch 4 satellites, 2 mirror images of each other, and 2 of them will slingshot off Jupiter and go to Saturn, and then one of them we'll go and have a peep at Titan, which is a large moon of Saturn, and then toddle off into space at only 38,000 miles an hour. And the other one will slingshot off Saturn, go to Uranus, have a look at that, slingshot off there to Neptune, and then go off into space. So that was the plan. So they asked for the money for 4 satellites. But every single expert he consulted in NASA said, go away. It's too expensive, it can't be done, electronics won't work out, cosmic rays will damage things, radiation will do this. He was surrounded by naysayers. But he kept at it. And this one was, come on, don't bother us anymore, go away, what do you know about it? You've only got a PhD, we're experts. And he said, that just inspired me to keep on and keep on and keep on. And he did. And in 1966, Jimmy Carter said, go. You can do it. Here's the money. Persistence paid off. But Nixon comes along and wants to cut the budget, so he cut it to two satellites. You can't have 4. They were still getting on with the shuttle. So they started what became called the Grand Tour of the 4 planets. Gary Flannery left the project at that stage. He was very, very junior, and he went off to become a professor at the University of Utah. And he comes back into the story much, much later on. Now, they have to launch a computer. These satellites have to contain a computer to control all the instruments and everything that's on it. And this is what a typical business computer looked like when they had the idea. And we used to run the Abbey Works with 2 of these. And if you're familiar with memory size on mobile phones, there's hundreds and hundreds of megabytes on a mobile phone. These things had 8,000. They were 8K machines. And they were as slow as a house brick, relatively. And they were huge, weighed a ton at least. And the idea they had was, right, we'll build a computer that we can put in a satellite. And they bought 3 processors. At the heart of a computer is the processor. They bought 3 processors from Texas Instruments for each machine. They put a magnetic tape drive on it, which looks even more primitive than the ones we used in the 1960s. And the idea was that all the information that would be collected by the instruments on the satellite would be downloaded into the satellite and squirted off to Earth, to a big dish somewhere, anywhere. The 3 satellites, 3 big satellite dishes around the world. So whatever they were, they could pick it up. And if Voyager was in the dark, like this, if a planet was in between us and the satellites on Earth, the receiving satellites, they just store the data on the magnetic tape, and as soon as they could see the Earth again, squirt it off. And the 3 computers did different things. One handled the geometry of the spacecraft, one handled the storage, and one handled the propulsion systems and so on. And that's a typical 1974 computer, and it was just 3 times as heavy and just as slow. So comparatively, there's more storage in your car fob than there is on these satellites, and millions more capacity on a mobile phone than there is on these satellites. And you can see it's quite a complex thingamabob. A state-of-the-art car at the time was a Morris 1100. And this is it sort of to scale. So there we go. And the Morris 1100 then was 650 quid. Can you imagine? And the satellites they built have got 11 instruments on them and an LP. This is what it looks like. Based on some earlier Mariner expertise, because NASA was working on putting people on the moon and that project, there was quite a lot of spin-off of technology from that project that they could leapfrog into this project. And it was nuclear powered. There was a little lump of nuclear material in there, and that powered the whole device. And you wait for it, it used 4 watts a year. That's how optimum it was. You think, a 100-watt bulb, it couldn't fire one of those. But they reckoned that this device could last for somewhere around 50 or 60 years, there being sufficient power to keep some of it going. And they could analyze what was going on out there, look at the solar wind, take all sorts of measurements. This thing was a very long boom. It was inside the capsule when it launched, and then it just unhinged and spread out. Checking for particles. This looks like I'd built it in my shed, but it's actually a very clever spectrometer. Massive 3 cameras, one of which became a problem later on. And lots of other instruments that will mean a lot to people who understand these things, and I'm not one of those. And then everything that was collected and squirted back to Earth. And of course, the further away you get from Earth, the longer it takes for the signal to arrive. But also, that was capable of receiving instructions. So if they wanted to change its angle or whatever, then they could send a message to Voyager. It would process it. Little jets would fire, and it could turn that way or whatever. They could do things with it remotely. But imagine trying to do something where you're telling an object to do something, and it's not till 24 hours later that it says, "Oh yeah, I know how to do that." And now the LP, which was the thing that was most talked about at the time. You could think of it as a message in a bottle, really. They were aluminium discs that were gold-plated and mounted on the outside of the satellite. And they had 116 images of life on Earth, because they had no idea who was going to read these things. Is there an intelligent life out there somewhere that can take it off, put it on its record player, spin it, and oh, that's interesting. And there were recorded songs by Chuck Berry. The Beatles, they wanted to put a Beatles song on it, but the chap who owned the copyright to the Beatles music wouldn't give them permission. Otherwise, the Beatles could have gone into space. But it said hello in 55 languages, 27 pieces of music, including Bach, Beethoven, as I say, Chuck Berry, a spread of things. Lots of photographs of people and things to try and explain what life was like on Earth. And it included instructions on how to play the record. But they had to write those in English because they had no idea what anybody receiving it was going to speak. Probably not English. And this was massively controversial because they wanted to show what we were like. And this was intense debate about this. And many people in America and in NASA and in the government thought that this was simply pornographic. You couldn't possibly put that. One suggestion from NASA was, well, we'll show the lady pregnant so that it'll explain something about us. The whole idea was Scotch, so they dropped the whole idea. They couldn't put images of themselves. They had to be satisfied with photographs of non-pregnant people with clothes on. And in 1977, off they go. One on the 7th of August, one on the 1st of September. And this was a state-of-the-art car at the time. Hands up if you had a Ford Cortina. Oh, there we are, 5 of us. And a gentleman by the name of Alan Cummings was the last man in this team who touched Voyager before it was put on top of the rocket and went up into space. And it weighed almost a ton. So it was quite a significant lump of metal. They went up on Titan rockets, and the whole project cost $865 million. Today, that would be around about 15 billion, I guess, thereabouts. And this was a photograph that they took not long afterwards of the moon and the Earth. It was the first time Earth had been photographed from the other side of the moon at sufficient distance to see it. And this was taken a bit further away, much later. And these are black and white photos. The cameras on it were only taking black and white. Because if you take stuff in color, the amount of data you've got to send back to Earth is 10, 20, 30, 50 times higher than if it's black and white. But if you put the black and white photographs through red, green and blue filters, you can regain almost all of the original colour. And so that's what they did. So this is what we looked like in colour. And these were the first photographs to come back from Voyager 1 and 2 of Jupiter. 18 months later. And it took them 3 months to transit the planet. So there was plenty of time to take photographs. And what they saw was that the satellites of Jupiter, each of them were unique. And there was a whole trove of photographs came back. And they discovered, which they didn't know before, that it's surrounded by a very thin ring. We know Saturn's got this ring around it because it's very obvious. But we didn't know that Jupiter had one. And then what about this? Well, this lady, Linda Morabito, was looking at the photographs that were coming in one day. She was just about to finish and go home for the evening when she spotted a photograph and thought, oops, that's weird. And this was the photograph. And she discovered there were active volcanoes on the planet. The center plume 15 kilometers into the air. And we had no idea before that. The ash cloud is 15 kilometers high. And these were some of Jupiter's moons. They've all got very fancy names like Callisto and Ganymede and whatever. But it revealed, the photographs revealed a huge amount about the planet and about its atmosphere and so on. Lots and lots of volcanoes. Having spotted the first one, it was easy to spot the others. And this is what it looked like on the far side, because part of it is never in the sun. So there's some fabulous photographs came out of it, and this was the one they originally spotted. But when they looked more closely, the whole surface is cratered. So what did they discover about Jupiter? Well, the volcano, lots of dust particles, lightning, auroras. It's got a smooth, icy surface with funny cracks. They discovered a lot physically about the planets. And the red spot, which had been spotted by astronomers many, many hundreds of years ago, are turbulent, fast-moving jets, atmospheric jets. And the wind speeds on some of these planets are over 1,000 miles an hour. I mean, we think Porthcall's windy. And then they get to Saturn. So everybody knows about Saturn's rings. Some of the particles in Saturn's rings are the size of a detached house. So that some of it is dust and some of it is quite substantial lumps of stuff that's flying around. And it has 2 moons and thousands of rings. You might look at it and think, oh, there's a few rings there, or it's just one multicolored one. Thousands of them. Fabulous, fabulous photographs that came back. And they discovered the rings were more complex. They found some more moons. No atmosphere really, predominantly hydrogen and helium. We can't live in that, and nor can anything we know. And the winds there reaching 1,100 miles an hour. And then at this point, the twins separate. And one goes off to have a peep at Titan, Voyager 1, and the next Voyager 2 carries on to Uranus. So they make the slingshot from there, and off they go. As they were exiting the dark side of Saturn, they discovered that they were having difficulty with the camera. The camera's mounted on the satellite, and they could orientate the cameras. So if they wanted to go that way, or, well, you know, when we're taking photographs, we do the same thing, don't we? You know, can you crouch so that I can get you in? Because I haven't worked out how to do that. And what they found was that the camera jammed. It's mighty, mighty cold out there, and the camera jammed. So they had to work out from hundreds of thousands of miles away, million plus miles away, how to get it working again. Otherwise, that was going to severely prejudice the intention of the project. And what they worked out was they would send an instruction to it, which you imagine takes some time to arrive, asking the camera just to try and move a little bit. Instead of telling it, move to that or do that, they move a little bit. And they sent it instructions repeatedly just to, what do we do when something's, we jiggle it, don't we? And so they jiggled it until it finally freed up, and then it was able to move. But they had some anxious moments, more than a few moments, hours, while they were trying to make that to happen. And Voyager 1 took pictures of Titan. It was the first time that we'd had a really good look at that and discovered that it's got an atmosphere. So it's, of all the things they've looked at, this is the one that's got an atmosphere that's most like ours. Still not enough to support life. But it's got canyons, like the Grand Canyon, which is unusual in these planets. So huge fissures in the land, very, very geographic. And then Voyager 2 gets to Uranus, which is a gas planet. This was 5 years later. So in that 5 years, many people in NASA had got married, had children, gone on holiday, done all sorts of things. No point, and nothing's going to happen now until we get there. So they could do whatever they wanted and come back for when they were going to be going past this. And they can reprogram it in flight. So as they're learning new things, they can adjust trajectories and whatever. Not very much, but enough. And they discovered they discovered planets they never knew existed, moons, sorry, that they never knew existed before. And they also found that the planets, we rotate pretty much, not quite horizontal, we had a slight angle. And some of them rotate at quite a curious angle. And they were going around the sun at different speeds, at different aspects, and so on. This is a good close-up of the rings of Uranus, which they didn't know before. And Miranda, many of the people in NASA said this was the most interesting part of the whole project, because they knew nothing about Miranda. It's just one of its moons. And many of them said, oh, this is special, this is really special, this is really interesting. It's got real geography, it's got mountains, it's got chasms, it's got a Grand Canyon, it's got all sorts of things. Sadly, when they discovered this, that was overshadowed by the Challenger disaster, if you remember. That took over everything in America for a time. But this was regarded by many people in NASA as the highlight of the expedition. So they discovered new rings, new moons. It had an atmosphere. They got some images of the largest moons. It had an atmosphere which they'd lost. So they discovered a lot of things that they didn't previously know. But also they discovered there was liquid moving around it, and that was the first. They didn't know that. Then they get to Neptune. That's the furthest one, 12 years after it was launched. And they've traveled 4.4 billion miles to get to this. And the trajectory they set, were all their calculations of slingshot and speed and whatever, they were 62 miles out when they got there. Slightest adjustment, got it right. Uranus and Neptune are much the same size. Again, this has winds of 1,300 miles an hour. And they get these windstorms, and they've observed now that they happen about every 5 years, and they have no idea why, because a year up there is not the same as a year down here. They're moving around the sun at different speeds and so on. But about every 5 years, along comes the big wind, 1,300 miles an hour. And some of the particles in the rings, again, are very, very substantial pieces of stuff that you wouldn't want to bump into. But it proved that Gary Flandreau was right. When he was arguing to do this, he said, if we launch in 1977, we can do this, not in the 30 years it might otherwise take, but in the 12 years. So what do we discover about Neptune? Well, it's got a dark spot, which is about the same size as us. It's got a ring system, it's got a magnetic field, it's very highly tilted, it's very complex. Small moons. The biggest moon is geologically active, so they've discovered more volcanoes out there than they imagined. But it's also one of the coldest bodies in the solar system. And this is us, taken St. Valentine's Day, 1990, from 3.73 billion miles away, and there we are. And Carl Sagan, who was involved in the project, obliquely christened the photograph the blue spot. And we are the blue spot. So if anybody needs persuading that we are indeed insignificant, just show them the picture. This was taken by Voyager 1. And interestingly, there was a controversy about taking the photograph. There were scientists who were saying this has got no scientific merit whatsoever. We shouldn't be wasting energy taking a photograph of us. That's just self-aggrandizement or whatever. So it was quite controversial, but whoever was running NASA at the time said, no, this is an important thing to do. We may never get another chance. So in 2012, both Voyagers popped out of our solar system, so they're now into interstellar space. They're going to send data for at least another 5 years, possibly 10. NASA are currently working out how to optimize the energy that's left on it to see if they can make it last long. But there's no reason these shouldn't carry on flying forever. They've got their own momentum. They're in a vacuum. So until they bump into something, like another planet or a rock or whatever, no reason they shouldn't run for a long, long time. And they're running at quite considerable speed. That's 10 miles a second. You don't even see youngsters along the prom doing that. And the darkness out here is seriously dark. It's twice as black as soot. So it's provided, this little blob has provided power for 50 years. So the question is, could it do more? Well, what they have done is to shut down a number of instruments. So only these 3 are left. They want to optimize the life as much as they possibly can. So I'm glad the one that was built in the shed is one that they chose. So the question is, what have we learned? Well, Gary Flanro's lesson is, don't be discouraged by experts. Persevere. And funnily enough, I've always believed in my life that there are times when you have to be distinctly unreasonable to get something done. And I think he was wonderfully unreasonable. He just chipped away and chipped away. One of the most junior men in NASA, nagging people who were world-established experts, just kept on and on. So we know that the other planets are cold, dry, volcanic, rocky, and there's nothing there. They are absolutely lifeless. So we're unique in this galaxy. And there's lots of other galaxies, as you know. And we occupy a sweet spot in the solar system, really. Mercury and Venus are too hot. These guys are too cold. And we're just about right. Now, you won't meet many people who will tell you that we're just about right, because often we aren't. But indeed, in this context, we are. We're the real sweet spot. Gary Flanro was well recognized, and he's a very accomplished engineer. Got many awards as a consequence, even though he left the project. He was the guy who started it all off. He's 91 now, still alive, living in Tallahassee. And I managed to get in touch with him on the telephone. You can't find out American telephone numbers from the UK on the internet. But I have a number of friends in America, so I just said, see if you can find me Gary Flanro's email address or telephone number. And within 20 minutes, I had his telephone number. So I waited until it was 11 o'clock in the morning, his time, and I spoke briefly to his wife, and I spoke briefly to him. I explained what I was doing, and I'd be very interested if he could pass any observations to me of what he thought of the project and whatever. He didn't sound entirely right, is perhaps the best word I can use. And he asked me to email him a copy of the presentation, which I did, and I haven't heard from him since. I know that he's still alive, because if he passed away, there'd be an obituary of him, certainly in the Times, and I read obituaries, I'm sad. So I'm assuming that something's not quite right. So what I plan to do is to print this off and post it to him and just see if I can get some response. But a very, very distinguished engineer. And since Voyager, the world's full of satellites. And Elon Musk has launched over 1,000 of his SpaceX satellites. So the amount of litter in space is colossal. And as these things get launched, then SpaceX itself is able to just slightly move its satellites, and they're constantly having to dodge debris from space missions or stuff flying around. So lots of adjustments being made. It's more space is more cluttered than you think. Look at this. You think, how on earth can you get through that without bumping into something? Especially if you're doing 38,000 miles an hour. By the time you see it, you've passed it. Starlink has had to make 144,000 adjustments to avoid bumping into other satellites and other objects in space. And the International Space Station is constantly adjusting where it sits because there's stuff flying past that, and you don't want to be in that and get hit by a meteorite or anything. And in 2026, they plan to go around the moon, and America plans to put men on the moon again in 2027. America's not the only people thinking about it. China is certainly thinking about doing it. And this is a lovely photograph taken from Orion, when the first one that went up on April the 6th of this year, which is us from the far side of the moon, with enough of the sun on it to get the picture. I think it's a beautiful picture. And this was the one that Voyager took in September 1977. So they're very unworldly and they otherworldly. So they've traveled about 16 billion miles. The first time that's more than a light year distant from Earth. 16 billion miles. And Hubble telescope projects that the satellites will move out of our interstellar space into somewhere else. And NASA scientists reckon that these two satellites could fly for another couple of thousand years. They won't be able to send anything back because they'll run out of poke, but they'll be out there. And if they ever bump into something, there's always the golden LP to put on your record player, your dance set record player on Mars or somewhere. Tell us all about us. So 16 billion miles later, here we are. And thank you for listening. Happy to take any questions or any observations or whatever, please.
Did you find a planet similar to Earth a couple of months ago? Millions and millions of miles away. A couple of months ago, it's on television.
Yes.
Similar to Earth. Yeah, you didn't mention that, but
No, well, it's not part of this, but the challenge that I've got when I put a talk together is I'm trying to tell a story about something rather than what's happening at the moment, because there's so much being discovered all the time that you've just got to decide where you're going to draw the line, really. But I do keep up with it, but the challenge is what you include and what you don't include. Ooh. No, I don't, actually. I don't. Oh, there we are. Right. Well, I'm glad we disagree. I'm glad we disagree because it wouldn't be any good. Yes, could well be. Yes. Yeah. No, that's right. Yeah, I just think it's unlikely. And I'm not an expert. Oh, no. No, it's all somebody else's work.
You kept using the word insignificant a couple of times.
Did I?
But isn't the fact that we're here and the only planet that's got anyone doesn't make us insignificant? There must be a reason for us being here.
Well, there's clearly a chemical reason for us being here. With the sweet spot that we enjoy in terms of distance from the Earth. So we've got everything you need for life. So we're very, very significant in that sense. But in a global sense, Earth is insignificant in the total scheme of things, albeit we are massively significant to ourselves. So I'm just trying to make the point that we're a tiny, tiny, infinitesimal part of a much bigger thing. Whereas there are too many people on Earth who think that we're the only things that matter. And for us, we do, of course. Oh, yeah? Well, thank you very much indeed.